this example, I have commented out my, if I can get the focus, cleaning of the PWM and GPIO so that the voltage is still running. Show logic low, that's because no wires are attached. Now expected voltage for the PWM is to be 2.805. And if we look here, got between the ground pin and pin 18, 2.85. 86, 87, all Horizon bit. Now, moving on, since the other pin is set high, the pin 23, which is on the other side of ground, should read 3.3. So I'm just going to move it over, trying to keep that ground one intact. And we measure 3.36. Oh, there we go. So, PWM control is working and verified. Here we can see the Raspberry Pi Zero with all accessories attached to it is pulling a nominal 5.17 volts and 0.31 amps. Alright, this is to show the power consumption while running the PWM script. So without running the code, we're at 5.17, 0.32. Run the program. And our power consumption has not changed. Here I'll be running the PWM script to observe the power consumption while the PWM and GPIOs have not been cleaned or stopped. Still at 5.16, 0.34, hit F5 to run. Alright. And we have marginal to same amount of power consumption. Here's a video showing my code. Get the right mouse. This is a basic Python script to generate a PWM signal on the GPIO pins of the Pi and then take a digital input. These are my declared pin variables. There's my arbitrary duty cycle. There's my setups. And then right there is when I take my inputs. And then I read out my PWMs. Originally, I was going to take in the same voltage that I was putting out on another pin, but discovered that the Pi cannot read at the frequency of the PWM it sends out. So for this experiment, it will be detecting a logic high or logic low on the pins. Via data sheets, anything around almost like a 1 volt, even though the maximum is 3.3, is detected as a high. And then somewhere around like a 0.6 volt is as high as you can get for a logic low. I will be integrating with the sensor block later on in order to achieve actual measuring of voltage. So when I run this, this will activate pin 23 to go from 0 to 3.3 volts. Pin 18 will be 3.3 volts at 75%. And then our inputs will be on 17 and 24. Okay, so here's my Python script again. It is set up to spit out the duty cycle and calculate what the voltage would be, get between the 3.3 volt max and that present duty cycle. Previous tests show it running at 75% calculated voltage, and then pins 17 and 24 showing logic high. Now I will run it again to show that it works at the 75%, and then change the duty cycle thereafter. Ignore the warnings. It's just because I didn't clean up the GPIO. I'll just run some tests. I'll clean that up real quick. Damn it. Alright, so running that again. There is a bug or a loose connection. Seemingly more of a loose connection. Trying to get these pins to stay connected long enough. I can get pin 24 to always correctly read logic high, and 2.475 is definitely within the realm of reading logic high. Let's try that again. Just for the sake of argument, let's beef up the signal. 95. Run it. Okay. 2.475 might be close to the threshold. I forget. So at 3.3113, we can see that the voltage reading highs on both. Now, if I drop the duty cycle, we will see that. Let's drop it to something easy, like 45%. Run it. Okay, so now we're getting well within. That just shows the lower boundary. I'm pretty certain these freaking jumper pins, at least the blue one, it's already the second pair I've tried. I'm always getting a loose connection. Those pins are soldered in, so there's no loose connections between the Pi 0 and the pins. So I'm just going to continue to step down the PWM voltage until we can see a logic low. So from 45, drop it to 25. Run it. Alright, so at 0.825 volts, we have achieved a logic low on GPIO pin 17. Now, pin 24 stays the same because, given the code, I just have that set as a high, right? So right there at GPIO.output volt pin, that's just set to high, and via the comments, high will just push it to the max for the GPIOs, which is 3.3 volts. To show, I guess what we could also show is, so the purple is what's pin 24 and 23. So if I just pull this one right here and then run it again, that will show that a logic low happens because no voltage will be applied to that pin anymore. And I might as well show you the same thing for the blues. So I'll set the duty cycle back up to, say, 85. Should be well within the lower limit. So I'll quickly run it to get a logic high, so I'm in the right window. And, oh, we're buggy again. Come on. Freaking loose connections. I'm going to swap wires and we'll try this again. Alright, I've added a sleep to my code to ensure that the pins are read before the cleaning takes place, as it seems that the pin 17 likes to drop back down the logic 0 before it's even achieved. So I will run this again real quick. 85% duty cycle. We should see a logic high. It's about a 5-second wait. Probably could be a little shorter on the wait, but just making it work. Now I will drop the, well, I've already shown dropping the duty cycle, so this time I will remove the wire. Might as well just pull out both. Without any edits to the code. Logic low. So there's the code running thus far. Thank you.